Okay, good morning. I think we're ready to get started. So I want to welcome everybody to this morning's presentation. I think you're really going to enjoy our speakers today and the topic. Again, my name is Ben Rodney. I'm with ASHRAE New York chapter. For those that don't know, it's the American Society of Heating, Refrigeration, Air Conditioning Engineers. We wanted to thank the organizers of Circular City Week and the Danish Clean Tech Hub for allowing us to partner with them to put this presentation together today. I just want to let everyone know this is being recorded. It will be available on our website later on. And I wanted to introduce and welcome our two speakers today for this awesome conversation about circular systems in the built environment. So I want to introduce my very good friend and colleague, Mike Izzo, who's with Hines, New York, and is working on some great projects that we have going on in New York City that are focused on circular economy, circular systems, carbon reduction, sustainability. So I think he's got a great case study laid out for you guys. And then also wanted to introduce Will Sibia, who's in with Urban Systems in Stockholm, who has worked very closely with Mike on some projects here in New York and has some great thoughts about the work that his company does in the Nordics and spreading some of those principles of the circular economy around the world, including here in New York. So welcome, guys. And so just so you know, if you have questions, we're going to do a Q&A at the end. Just put them in the panel on the side, and we will get those answered as soon as the presentation comes to an after the case study. So the way we're going to do this for the first 30 minutes, we're going to do it as a kind of a conversation between Mike and Will. I'm going to ask them some questions. They're going to play off each other. There's a few slides to show you what's going on, and we'll go from there. You guys ready? So Will, I think what would be great is if you could kind of walk through what Urban Systems does, why the circular systems are important, how do they relate to the built environment, and then kind of give some examples of what the Nordic model and history is. I think that'd be a good way to kick us off.
Yes, hi everyone, and thanks a lot, Ben, for inviting me, and especially on this topic, that's very close to my heart. And I think it makes it extra special. I'm sharing this dice with Mike Izzo. I mean, if I have to put it, he's a partner in crime. It's been 3 years since we've been working together, and it seems we're making good progress. So yes, my name is Will Sibia. I'm CEO and founder of Urban Systems. I'm based here in Stockholm, and I'm a mechanical engineer by background. Did a post-graduation in sustainable energy at Royal Institute of Technology in Stockholm, and did some executive education at London Business School. So we are essentially integrators that try to integrate knowledge, technology, and finance, and in terms of bringing the solutions as close to the end user as possible. And the reason why we're doing this is because we think that if we can give an alternative solution to the end user, that's the best we could do to give them the options so they can make informed decisions. And I think for us to be working as integrators, we need to work very closely to developers and investors and allow them to make good decisions as well. So we are a commercial arm to the Swedish industries export platform, which is called Urban Tech Sweden. And why we started that was essentially we saw a very good market in terms of promoting some of the solutions that Sweden and the Nordic countries have been doing when it comes to built environments in terms of energy, water, wastewater, transport sector. But there was no one who was filling the gap to give the solution. So that's how we saw market demand, we saw a need, we saw possibility to do it, impact, and that's how we came about. So we first started just as a platform, as a not-for-profit. Then we realized we need to be a commercial actor that's very agile, And that's why we said, okay, let's think of this as a startup. So we're agile, we're flexible, and we can go into different institutions and different sectors and try to be focused on solution, because what we're targeting is a pretty complex problem from the outside, but we want to give a solution that's simple in terms of application of that, and that can be scaled. So that's what we do at Herbs.
Sure. And so, can you talk a little bit about how you think circular systems relate to the built environment, specifically, and maybe go into some examples or thinking behind that?
Like I said, we really need to appreciate to see where we are today. We are living in these times with pandemic, and it has really been, we've never been exposed to such an environment before. And if you start comparing what's happening with the pandemic, with COVID, and then we put into context of what's happening to climate change, we can learn a lot, and it's pretty scary, because that shows that if we don't have systems in place that can address any problems that are unforeseen, and we're actually not paying attention to what the scientific community is saying, it can be pretty bad. And climate change is a societal problem. And we were just discussing before this talk, obviously, that there's no vaccination against climate change. And also, you're not going to get herd immunity. So when we see today the current systems that are made, that we are living off, and the whole economy is working, they're very linear. Economies, production change, they're built on increased supply. And also, we have reduced the production units. We look at energy, there's very small number of very large producers. And even when we think of material supply, if you look at US, for example, there's so much material supply that happens from China. So essentially, we've created massive mammoths of production houses that distribute the resources through masses, and the masses act as supplying the income stream to these resources. So we have created a system where increasing the resource use is directly related to increase of income. And I think that's what we need to change. We need to decouple the resource use to the economic generation. And when it comes to the Nordics, I can give you some quick examples. Is Nordic countries, to be fair, they started with inherent good base, smaller population sizes, pretty democratic or very democratic setup. Citizen participation has been high. And also they've been able to use the industrialization, because they were highly industrialized, to keep the energy consumption per capita steady whilst increasing the GDP. And there's some things we can learn from that. All countries have good and bad examples, but I think when it comes to energy transition, Nordic countries are ahead of the curve, and they have one of the most ambitious policies when it comes to climate and energy globally. And one of the key examples, before we get into more core discussions, and Mike will present examples in New York as well, I think, is the decarbonizing of heating in Sweden. This is almost a textbook example how the policy side, industry, and consumers actively work together, pushing each other. Obviously driven by oil shocks, and more informed users allowed this to happen, but they have been able to decarbonize the heating network. And that has allowed the energy transition to happen very smoothly and successfully. Of course, there's Nordic countries also, if we have to meet the 2 degrees target or 1.5 degrees target, they have to think even more out of the box. So there's a long way to go. I'm saying in no way making this problem sound very simple to deal with, but I'm saying we have certain examples that can be replicated, so we don't reinvent the wheel from some countries of the world, some parts of the world that can be contributing to certain parts of the world. And these ideas, technology solutions, if scaled, can allow us to combat climate change effectively and quickly.
Mm-hmm. Yeah, and I guess, Mike, what is it? So, I remember a couple of years ago when you got so excited about being able to go over, travel to the Nordic, see some of the examples over there. You've been preaching some of these principles over the last few years. What is it that got you saying, "Hey, this is where these are the topics that I need to get smart on. This is what we need to bring to New York, and this is how I need to drive my projects going forward"? What drove you to get more interested in this?
Yeah, thank you. It was quite an organic process. I mean, when I met Will and his team here for UN Climate Week in 2019, it was almost that an internal switch had been set off inside me, just to see their simplistic, high-level thinking, holistic thinking, both from a technical and an economic standpoint, as well as the inspiration and optimism that they had. I think that's key in driving innovation. If you come to the table with a pessimistic attitude, you will never progress, right? So their optimism actually inspired me. And then when we went over to the Nordics to visit, different central heating plants or a variety of different buildings and how they were all connected and how they, had this sharing economy and how they used wastewater and many different technologies and energy flows that we currently have in our system in a more circular way, it was just quite simple. There wasn't any progressive technology. Will wasn't trying to sell me the latest, greatest shiny toy. It was just systems level thinking, both from a technical and economic standpoint. And that's what really drove me to say that this can be scaled and this does not have any risk.
And so I guess it's that simplicity of it that you felt might be able to allow you to bring that to a city as complicated as New York, and bring these ideas to Hines and our organization, but also to others in our industry, and say, guys, my eyes have been open. Let's start thinking about it this way. It seems like maybe that simplicity is what allowed you to do that.
Absolutely. The simplicity takes the risk out of it. It gets more people on board. It guarantees the success going forward. The more complicated something is, the more explaining you have to do, the more marketing you have to do, the more effort you have to put behind it. But using the tools that we have in our tool belt is key to get everyone on board. And that was the exciting part. I mean, we're talking about electricity, heat pumps, wastewater. I mean, this is not anything that's really exciting by itself, but putting them together to really harness the energy that's already there. We have what we need. That was the exciting part.
Yeah, that's great. I know you're going to get into that more in the case study. So Will, can you talk, and I know Mike just mentioned systems thinking. Can you talk a little bit more about systems thinking and energy generation and consumption at the systems and building level?
Yeah, yes, certainly. But I mean, just to take on Mike, when Mike came here, we had some significant progress before he reached Stockholm, and we went to Copenhagen as well, and different parts of Sweden and Denmark to look at the solutions. But essentially, I think, Mike, if I may just put a question as well, I mean, the perceived risk, and this we have spoken a lot about, like the risk that is perceived from new technology or new idea or new solutions, that is probably one of the biggest bottlenecks to transformation. It is not necessarily a risk.
Absolutely. I mean, even in the technologies or case studies we'll talk about today, I define the perceived risk as doing anything different than the guy next to you. That's the perceived risk. So in New York, I feel like we're a very process, task-oriented, driven society. very efficient society. When I went to Stockholm, I just saw a whole nother level. I got told a couple times to zoom out just a little bit. So they take a much more holistic 30,000 foot view and then dive into the details. Whereas here, I think we stick to our lanes a little bit more than needed. So yeah, the perceived risk is really doing anything different than the status quo.
Definitely, and I think this behavioral change that's needed for us as individuals. So firstly, to find the individuals who are motivated, to take this, and also to allow these individuals to take active decisions, be part of the decision making, and have this capacity both through knowledge or through influence, and instead of just being herbs integrated, and this me and Mike have discussed as well, that we want many people who think like herbs, like how can I put solutions together? How can I try to convince people to just think differently? It is not necessarily new technology. And there's actually no new technology that we need to deploy at this moment to take the simpler decisions and steps. I mean, if you look at LEDs, the technology and the scalability of LEDs and what it did to energy efficiency, it's pretty amazing as a story. So I think in this case, when we talk about heat and more dense energy usages, especially at the downstream, as close to user as possible, which is thermal energy, heat and cold, I think we just have to think in the same terms. So storytelling goes a lot further than just technology.
Yeah, I would say the same thing about facts. You could tell people the facts all day long, it's not going to move them. If you tell them a story, and I think the story needs to come from many different angles, not just the technical angle, which is why I love being a pupil to Will, not only a partner, but a pupil. It's the economic, technical, socioeconomic, it's all those ideas collaborating with as many people as possible in order to get the solution over the finish line. And that was the success that we had in New York with the projects that we'll be showing, is that it wasn't just me and Will, banging on the door saying, hey, you need to look at this. We started to get, a few people on board, then a few more, then a few more. Then we collaborated with academic partners like UC Berkeley. We brought in many, many people to, test drive or, comment on the solutions we were providing. And the truth was no one could put a hole in it, because it was just good systems level thinking that was financially beneficial, environmentally friendly, and better for society as a whole.
That's Go ahead.
And not to mention NYSERDA and the partnership NYSERDA and their support through the whole process. And, that has been phenomenal as well, because we see, we need to have different stakeholders at different level, and all these stakeholders need to be aligned. So a single stakeholder in this process can actually stop the whole chain.
Yeah, I always say if you ask the same person the same question, you're going to get the same answer. So if you ask the question from the same vantage point, you're also going to get the same answer. So NYSERDA has been a tremendous partner, as have others, but getting different viewpoints just makes a better story and makes a better solution, really, and gives you the maximum uptake into the market.
Sorry, I think I sidelined the question, Ben. So the systems thinking, essentially, if you look at the basics of circular economy, just the basic fundamentals of circular economy, how do we stop taking in more resources, more virgin resources, more recycled resources to generate productivity, generating economy? And if you put that from the energy transition point of view, there's only two ways you can do it. Either you put in more clean energy into the supply side, or you actually reduce the energy that you're using and allow the uptake of renewable energy at the end. Those are the only two ways. Of course, there's different elements to it, but that's the only way you can decarbonize your energy that's being used. And if you look at from the energy productivity point of view, because the supply side has basically sucked the air out of the discussion on energy efficiency. If you look at the investments going into renewable energy, big utility scale plants, wind, solar, you know, if you're investing $1 billion in new energy compared to if you invest $1 billion in reducing the energy, the downstream effect is massive. I mean, you're allowing the communities to keep the money within the communities itself. I mean, the social equity in this thing, or the energy distribution, and we're talking about the fuel poverty here as well, to the most vulnerable, is massive. Because most of the time, the risks are being put to as down as possible. And same as the economic pressures. So the most vulnerable society, or the most vulnerable in the society, are often forced with the maximum risk that the system has. So when we talk about circular economy, it just does not make sense from climate point of view. It also makes sense from the social growth point of view. And normally we are talking in terms of capacity, capacity markets, because that's driving the financial models and economic models. Like every year there's a growth in selling of energy, and that energy of the selling of energy is linked to the directly proportional to the resources being extracted. So if we think from the linear point of view, we really need to change to the circular thinking, but we need to start from the bottom up. We need to reduce the energy first and think from the energy productivity to energy efficiency. So energy efficiency is you're driving more from same resource, whereas energy productivity is you are creating more from a resource. So in terms of very simple, even mathematical models, it makes sense, but it's the discussion and the multiple stakeholders that are often involved in driving energy efficiency that are the bottlenecks or the challenges here. So that's where we need to bring in systems thinking.
And I think simply for me, to put that all into just a couple words, it's really designing out the waste from the onset. Not what do we do with the waste after this linear production system arrives at our buildings, and using the buildings as an asset, not just a liability on the energy network. So how do we use the buildings to store both electrical energy, thermal energy, and any other type of energy we can harness? And I think that's the key. And to Will's point, that's at the local level. Those renovations will happen at the local level. You don't need to provide such a large infrastructure system that's thousands of miles away. That investment could be made locally and benefit the society in that local community.
And Mike, that's a great point, and Will, I think your points there are excellent. Do you want to talk a little bit more, Mike? I know you guys were talking about the different stakeholders and the work you did when at NYSERDA and some of the stakeholders with academics and the folks at UC Berkeley and some of the agencies at the state level. Can you talk a little bit more about how you see these concepts manifesting themselves in New York and how those stakeholders might be involved? And Mike, that might be a better question for you.
Yeah, like I said before, the maximum collaboration is key. I think there's definitely, legacy laws in place that might prevent us from doing things. I'll never forget when Will and his team came and sat in our office at 345 Hudson, and we were talking about a development site that was nearby, and they said, "Why can't you just use the river water?" I said, "Oh, forget it. You'd have to talk to," and it was the Hudson, right? So you'd have to talk to the Port Authority, all sorts of different federal agencies, et cetera. It'd be a complete nightmare. So I think just in general, even the sharing of resources in Stockholm, what they have is a smart thermal energy grid, right? So they have a peak production system, but that peak production system is expensive and no one wants to utilize it, only when absolutely necessary. And they use the buildings as more of the efficient energy plants that can be efficient all year long when needed. Only on the most extreme days would they need to take energy in. And that's how they kind of design out the waste. So I think here sharing thermal energy between buildings, between pipes. I mean, I worked in the hospital world, and we had a campus, and we ran piping in a tunnel underneath, you know, the streets of New York to send it over to another building and create our own thermal grid at a hospital level, because we saw the value. It made economic sense and it was efficient. So there's many different stakeholders. We push a lot of the decisions down to people who are not willing to take the most risk either, right? So a lot of the risk gets pushed to the lowest guy in the totem pole, and who may not have the same interest that you do financially or other aspect of sustainability. So hope that answered your question, but I think there's a lot to be done there. I love the conversation yesterday about prosumer buildings and the network at large. You know, I started with I was lucky enough to be in the Urban Design Forum Fellowship a couple of years back, and we had a huge idea. It was take Rikers Island, use it as an innovation hub, do agricultural vertical farming there, use that to feed Hunts Point, use the scraps of Hunts Point back to the anaerobic digesters and the wastewater treatment plants to be sent back to compost. The wastewater could be used as irrigation. The energy from those digesters could be sent to the grid as heat. I mean, there was this whole circular approach. So I don't think we should just be talking about buildings, but we should be talking about all the stocks and flows we have. Because, you know, New York City alone discharges 1.3 billion gallons of water a day, and we heat that water up to be treated. So if we're able to utilize it and take it out as a waste stream, then how much cleaner do our rivers get? How much better does our air pollution get? So yeah, I think there's some big ideas there too.
Sure, and I know some of the things that you had mentioned in our preparation conversations are breaking down those silos and collaborating to realize the co-benefits of the circular economy. Maybe, and I know we wanted to make sure we got to this point before the case study, so maybe it's a good time to transfer to the social impacts that the circular economy and the built environment can have. Well, I know this is a topic that you're passionate about, so maybe if you want to kind of talk about how some of these ideas can have very beneficial social impacts for the world at large.
So, I mean, how I see it is essentially, you know, we are putting government and regulatory authority at the center of it. And the three key pillars: the investors, the businesses, and the people, you know, because people influence the government through the votes. Of course, we cannot underestimate the businesses influencing the policy and lobbying efforts of the government and the investors investing in. But if you see there's weaknesses in the system, is the government is taking decisions on a very short-term basis. So most of the governments, you know, especially democratic governments, they are forced to listen to majority thoughts, majority votes, and they are in some way restricted by taking long-term decisions. And the investors, they also see the perceived risk aspect that we had discussed before. So yes, ESG was a great framework, but if you see which are the companies, you don't even have to do a lot of research. If you just go and look which are the companies getting the most of the monies under ESG, you'll be surprised, like, how is this contributing to the social growth? You know, so again, how as a society, how do we work? And businesses who are working in a certain way, for them to change, especially during this past, I would say 40 to 50 years when we worked on the consolidation model. One producer, many distributors, you know, large producers. For them, just the inertia of business as usual is so strong and so large. For them to change is massive. I mean, just recently, if you look at Tesla, how they have transformed, you know, the car industry, and you still see how very large industry players are not able to catch up, because there's all down the business streams they still have business as usual inertia that's going in, because people are used to working a certain way. So I think when it comes to social impact, And this, we just had a very brief chat before this as well, Mike and Ben. Like, we are very good that all these people, investors, businesses, governments, and individuals, we are very easily, we can make the climate change as someone else's problem. We're very good at, sending the problem away. We look at the landfill we discussed in New York City, but New York City doesn't have landfill, but it's going somewhere. Is that being treated? We know the Maldives or coastal regions are in trouble already, but we are making that an extra problem. So I think the nexus here, of course, the governments are seen as the drivers, but essentially the people around, the businesses, investors, and individuals, we need to play a bigger and important role. And if we start creating the circular systems and we start retaining the money and generating economy downstream with the infrastructure, and the monies are not going externally to oil producers, fossil fuel producers, or not local producers, you're instantly building societies that are more advanced, that are more integrated, and that are contributing to the development of not just economy itself, but to the societal growth.
That's great, Mike. Do you have some thoughts on that?
Yeah, a couple of things that not as eloquent as Will, but I was just thinking the other day, what if we, I have a house upstate and everyone talks about getting out of the city to get, fresh air. Well, what's fresh air? If all the buildings and cars in the city did not burn fossil fuels, you'd have fresh air right here. If we weren't polluting our waterways, we'd be able to swim right here. So I think there's something powerful to that that gets overlooked quite easily and doesn't get put into a financial framework. How do we regenerate? Because a big part of the circular economy is regeneration of our natural ecosystem. And we're in a linear model, we're just destroying our ecosystem, not even sustaining it, right? So sustainability is probably a bad word. We need to regenerate it at this point. So I think from a societal level, it's key, and keeping the cost down as well, right? We don't know, oil is not an infinite resource. It's heavily subsidized. And there's questions about renewable and how it gets implemented, but in the end, it will drive the cost down of energy and affordability to everyone.
Absolutely. I think that's a very important point, because we need to give consumers an alternate that has the same price to the quality, which is not sustainable. So if we're not able to come to that level, and we depend on the consumers to make the right choices, then we're very far away. I mean, we're already very far from achieving the thing, but then it'll be even harder. So that's why we have to work and create solutions that are as close to the end decision maker as possible and give them the alternative.
And the benefit, if we're able to implement those solutions at a local level, is a third of the cost to implement it on the infrastructure level due to all the losses and everything else. The lowest cost of electricity across the globe last year, 90% of the infrastructure projects that went forward were solar. Now you can say, well, we need battery storage, you need to take that into account, but still the lowest cost of electricity is renewable. So there's many financial and social benefits to that, and affordability as well.
That's great. So I think what we're going to do now is transition to the case study. So we are starting to get some questions. So this is fantastic. People are paying attention. I hope you're enjoying this presentation. So if you do have questions, please enter them in the question box. We'll get to them in the last 10 minutes or so. So we're going to go to Mike now, talk about a project, some of his thoughts around energy, how he came to be working on this project 561, and then a little bit about an innovation lab that he's working on. So take it away, Mike.
Perfect, thank you. I'll try to go through this quick, just to share some of my knowledge, my inspiration and experience from visiting the Nordics and working with Will over the past couple of years. So this is the energy outlook as I see it, or as EctoGrid sees it as well. The way we look at energy is on the left. The way the Nordics look at energy is on the right. The massive amount of wasted energy that's just expelled into the atmosphere. And looking at the pyramid, the best energy is the energy that's never used. The next best is balanced. Obviously, buildings and societies are never perfectly balanced. So the next best is stored energy, stored surplus energy. Then we look to renewables and then fossil fuels. This is just 2019 energy flows of the US economy. And the US, I believe it's the EPA, has tons of data on this. And what's striking to me is how much rejected energy there is within the system. We only use 33% of the energy that we produce. 67% of it is wasted, 65% of that is in generation. And then in the residential and commercial sector, it's 35% each. And what that tells me is that the wasted energy on the electrical generation side can eliminate the need for heating in the residential and commercial sector. So before we get into the case study, just typical energy systems in buildings, I break it up into two parts: your energy production side and your ventilation and thermal comfort side. On the production side, we have two very linear systems, two different fossil fuel products, electricity, natural gas, different systems not connected. We see a lot of wasted energy through hot flue gases and rejected heat from AC units, just moving heat from inside the building to outside the building. Then we decide to couple all that in our distribution system by coupling ventilation and thermal comfort. What we did in our case study in the new development is actually reverse that and flipped it. The production side should be the side that we close the loop on, and the ventilation side and thermal comfort side should be the system that we break apart. And the reason being, to harness all the energy that we take in from the grid and keep it as local as possible to the building, use it as an asset for the building at a later time, as well as splitting the ventilation and heating and cooling aspects of the building to make those systems as efficient as possible. When we couple them, we're only as good as our weakest link. And some of the component parts on the production side, we say electrification. All our buildings are electrified. We all have massive AC systems. A heat pump is no different than an AC system in reverse. Put that graph on the left, because if you dive into that graph a little bit more, what it tells you is that we do not need very hot and very cold energy sources within our buildings. You know, the days of using 180-degree water to heat the building, you don't need 180-degree water to heat the building. We're using 95 degrees and 60 degrees on the chilled water side. And what that does is increase the efficiency of your heat pump to a very, very high level. So generally heat pumps, and we also have a dry cooler, 6 times more efficient depending what mode you're in. We have no cooling tower on the project, so we have 8,000 gallons of water saved annually. That's only from the cooling tower. If you take into the electricity savings, it's actually even more. And this water to energy nexus is something we don't talk much about because New York City is very abundant in water, but when you get into other parts of the country and the world, it's a real problem. On the ventilation side, we chose a DOAS system. We're bringing fresh air, outside air, filtered direct outside air directly to the occupant zone on the floor. We're not sending it into a mixing box or an air handling unit at the mechanical room somewhere. We're eliminating the large recirculation air and delivering fresh outside air to the occupant itself. That allows us also to do 80% energy recovery and also give us better indoor air quality. On the energy delivery side, we said, what's the most efficient way to activate the building from a thermal standpoint? And this came out of actually some architectural constraints that we benefited from the opportunities. We used radiant slabs for heating and cooling. That allows us to thermally activate the entire building. UC Berkeley did tons and tons of studies, and their studies show that it's 16% greater thermal comfort, and the utilization that we need to activate that structure is only between 60 and 80 degrees. So now our system efficiency is a lot better because we're not making very hot or very cool water. Whereas in a typical building, you would be blowing a lot of hot air and cold air throughout the building. And from a thermal comfort standpoint, we do not take into the radiative effect that we have, and you can understand that if you're sitting next to a cold window on a very cold day, you feel cool. So this activates the entire structure and makes the entire structure warm and comfortable, as well as providing the greatest ventilation and outdoor air quality benefit. Then lastly, but definitely not least, we were driving piles 150 feet, about 100 to 150 feet down to bedrock. So we took the opportunity to put tubing within those piles and use it as a geothermal system. And before going to the Nordics, I always thought about it as free energy, but the reality is that it's also storage. So not only is it energy you can take up from the ground, but it's also energy you can store in the ground to be used at a later date. This provides about 40% heating and 25% cooling to the building.
And just so people understand, this is a real building. I mean, I'm watching it being built outside my window right now, watching those piles go in. So this is a case study, but it's an actual building that we are constructing right now, not just something in theory anymore. So I want to make sure.
And I would say that we're installing even the radiant slab. Everything that we're talking about here will be installed by us day one, just to get over the hurdle of the perceived risk. It'll be installed, it'll be functioning, it'll be commissioning, it'll be operating. So why is this solution so great? I think I tried to capture it in this slide, but for me, it's the integrated approach to it, right? We have 4 modes of energy production. We have air source heat pumps, water source heat pumps. We have the geothermal system. We have dry coolers. So we have 4 modes of operation. We're not beholden to the peak efficiency of that equipment on a peak day. Every piece of equipment can be switched on or off based on the temperature and the climate on any given day. The other is 2 modes of thermal storage. We can store that energy when it's not needed into the radiant slabs or into the piles. So we're able to do that by preloading the slabs, dropping the temperature by 2 degrees. Dropping the temperature in this heavy concrete structure by 2 degrees is a massive amount of energy. It'll feel very little effect on the thermal comfort of the building. And all that is to say that we've reduced, even by electrifying the building, we've reduced our electrical consumption compared to a typical boiler, cooling tower, chiller by 20%. And right now we're projecting we're 50% below the 2030 targets that are set for New York, which are quite stringent, and about 80% of the buildings in New York will be facing fines as a result. But we shouldn't stop at operational carbon, because the day we build the building, the embodied carbon is equal to 30 years of operational carbon. So the day the building is up, we've already committed 30 years of operational carbon to the atmosphere. And one of the big, because it's a heavy concrete building, one of the big offenders is concrete and cement. And when we look at concrete, cement is only 70 to 20% of concrete, but it's 95% of the CO2 footprint. And a lot of that has to do with the chemical reaction and also heating the kilns up to 2,700 degrees. So the way to combat making cement is replacement strategies. So we've looked at fly ash, slag, but the most promising for me is the pure glass positive. So taking MRF from municipalities that end up in landfill today, taking that product, recycling it, cleaning it, and using it to store or as a cement replacement within their building, reducing the embodied carbon. Right now, we're doing a bunch of studies and tests. So that 30% is probably the minimum reduction of embodied carbon that we would have, but we're going through that currently. And then, you know, everyone's probably thinking, yeah, Mike, that's great on a new building. Well, what'd you do on an existing building? And this is exactly what NYSERDA tasked us with, along with a few other developers in the city. How do you take a 1930s pre-war building and bring it up to the same level as 561? And this was the result. So we looked at many different strategies, and all of them came in 30 to 60% of what the status quo would be. And the reason for that is we took it out as a whole aggregate, right? So each each floor, each exposure, each occupancy will have a different utilization across the day, the year, the month, and really connecting all those buildings in order, or all those floors, in order to harness that wasted energy we found that 15% of the time, we could actually shut our energy systems off and just share the energy between floors to significantly reduce the energy within the whole building. And I think this maybe describes it a little better. We have different devices, heat pumps on each floor. And if you think about even a DX building today, you have heat pumps, they're just stored within an air handler. So here we broke up the air handler and we stored it into its independent parts. A water source heat pump and a DOAS unit, connected the loop and closed the loop. So now we have the sharing of energy between each floor, and the peak system at the roof only needs to put in the net energy required for the building. So what we call this is energy arbitrage, essentially. And then just bringing it back a little bit to circular principles, really, as I mentioned before, designing out waste and pollution is key, and then keeping products and materials in use longer, and you could even say energy as well. The Ellen MacArthur Foundation has done a tremendous amount of work on this, obviously, in these 4 pillars, the power of the inner circle. How do we get the wasted product into the system as quickly as possible? With heat pumps, you can do that. You move heat. You're not creating heat like a boiler. You're moving heat from one location to another. So put it back into the system where it's most beneficial and utilized. The power of circulating longer. How do we get that energy to stay within the building as long as possible? Well, the thermal storage aspects of the geothermal piles and radiant slabs. And then the power of cascading. You can look at this 2 ways, both from a material perspective and the glass recycling that I talked about as cement replacement, but also even across systems in buildings where you have a heating system or a domestic hot water system. How do we cascade systems in order to share the energy where it's needed at that given time? And then the last is the power of the pure inputs, and that's designing out hazardous waste, because there's no value for hazardous waste in society. So when we talk about all the renewable energy and all the battery storage that needs to go onto the grid, we actually look at this building as combating that and not needing that battery storage, because we're able to take the energy in when it's most renewable or the cheapest, or however you want to say it, store it thermally to be used at a later time when energy costs are higher or less renewable. So I think that's a big key factor, and appreciate you guys listening to it and happy to answer any questions.
Yeah, that was great, Mike. I think we're right on time, so this is great. We have a number of questions from the audience, so I'm going to throw these out there for you. So one of the earlier questions, and maybe either of you can answer this. So there's a question from Emily. For money to stay in the community, does that mean ownership of the systems needs to be the community itself, or can you include outside investors and still achieve the social impact? I can repeat that if you need, but maybe Will, if you want to comment on that.
Both. I mean, if you look at the community itself in large, where is the economy being generated? So if less money that's going out of the community, regardless who is gaining, you're spending less money that goes to resources outside. So even if your neighbor is earning because they're selling you energy instead of a very large production house somewhere else, you're giving the money to the neighbor. So I think in that aspect, it doesn't really matter as long as you spend the money in your surroundings. If the economy changes hands in the surroundings, the productivity of the dollar increases, right? And then, of course, to implement this infrastructure, we can have investors, because from an infrastructure investment point of view, it's no difference to normal investment. And why I say that is because someone is investing in the other infrastructure as well, where you're paying. So this infrastructure would be smaller, decentralized local infrastructure that can have an external investor that'll have same principles of making money, but it'll be more sustainable, more circular. It's same thing as a 561 example that Mike gave. It made economic sense. The project made economic sense, And this we started like in 2018 and 2019, early on, you know, when Mike, you know, he said, okay, well, how would you do this? If this is the project, how would you do that if you're supposed to do that from your perspective? And when we came to the concept of high temperature cooling and low temperature heating system, you know, it was quite far off from implementation, but what was very evident was the investment opportunity was still there. So I think the question is, yes, you can have the investors still investing in, but they'll be investing in community infrastructure, both in physical and economic.
And I would say too, at that level, you would also have more control, right? How much control do we have on the investments that are made at the infrastructure level versus the local community? And when you look at companies within the local community, I mean, they generate taxes. They have, you know, many different income streams and financial impact to the local community itself. So I agree with Will. It doesn't really matter as long as it's local.
We have a question from Tommy and Mike. I think this might be in direct response to some stuff you were talking about. So it's a question of he is a chair of a water authority and water use has gone down, but the cost of the system remains constant. So they're having to raise rates in order to compensate. He feels that energy efficiency does not necessarily mean there is a savings and the funds are available for reuse. How do we compensate for the fixed costs of the system? I don't know if we necessarily have an answer for that, but wanted to see what you thought about that, if anything.
Will, you want to take that since you have a lot more thermal grids in the Nordics? I think, you know, you could say the same thing about natural gas, right? As people start to move away from natural gas, what's the investment infrastructure of that system? Wastewater is a little bit different of an animal, but you know, I mean, the solutions that we're providing, they will be utilized. The world is only getting warmer. We've seen, I've graphed, you know, New York City's weather for the past decade or few decades since the 60s, and you can see a natural trend upward. It's self-evident. So more than ever, I think these systems will be utilized, and they'll be utilized in more of a sharing way, which will be resilient in the future.
Yes, and I mean, if you have made the system, if the system is designed for infinite supply, that every year you need to increase, else the infrastructure cost doesn't stack up, then that is a problem. And that's a problem with a lot of linear systems. Look at the grids. The current grids, if you have to build the current grids that we have today, and these are probably built in the 1950s and 60s, there's essentially no financial model that can justify those grids and the costs. There's no investor who can say, okay, I can rebuild New York's grid. There's different companies who will come and run the grid and try to optimize. And when they say optimize, we have to be very careful. They're optimizing still the supply to the end user, so they can use the same grid to maximize or increase the energy by the end user. They're not optimizing the transfer of energy, because electricity is just a medium of transfer, but it's directly related to the investment returns, directly related to the business model they've done, because they will show they've taken this model, they'll do smart things, smart metering, because it'll end up increasing the electricity supply. And I think that's probably true for all infrastructure, gas infrastructure. You know, all the gas, if the gas prices go down and it's not utilized, the fixed cost still remains the same because it's made for unlimited massive supply.
Gotcha. We have a number of questions here. I want to make sure we get to all these. So Mike, this is for 561. So just can you expand on, have we accounted for improving indoor air quality or ventilation to ensure fresher air to combat COVID-19 issues?
I think our focus has been on indoor air quality. I would say that a vaccine is more effective than any indoor air quality measure that we could provide, and we're very careful in not stating that we can unless we have scientific proof that we can. So I don't think the science is quite there yet. It's getting there. We have a couple of collaborations at Hines Central level with the Mayo Clinic and others to determine that, but I would say that I'd be hesitant to make that statement in any building, even the latest and greatest state-of-the-art building, just for what I mentioned before.
But we have provided, we're doing direct outside air to the spaces at a percentage that's certainly higher than code. I'm not sure what percentage we ended up doing. But.
Yeah, so we actually have capacity to go anywhere from 20 CFM a person to 40 if we choose to do so. So the infrastructure is there. We have the filters. We're actually looking at carbon filters now. So there's a lot of separate measures, but not specifically related to COVID-19, more specifically related to indoor air quality.
Sure. And then this is an interesting question. I know you've thought about this and get this sometimes. So with your example of 100 AFA, if you're creating a structure that's going to thermal share within the building, how does this work when you have multiple tenants that want to control their own space? What's the thought process there?
Well, I think naturally everyone will benefit, right? So on that example, what we're doing is providing a much more efficient system for the tenant and a much more efficient system for the whole building. And the whole building only provides the maximum energy needed. It's basically just topping off the tank. So everyone wins in that case, and you can't say that one floor is going to benefit more than another because there may be times where that differs. So we haven't, formed a financial structure around it, but we think it's very powerful from that standpoint and the reduced energy efficiency on both sides, and also doing it in a scalable approach. Renovations happen every 5 to 7 years. Whole building repositionings do not. So we can, everyone's worried about the transition, and the transition is messy, right? We know what the end goal is, but how do we get there? And this is a way to kind of take a smaller bite at the apple and still get to the same point.
Right, and Will, I'm sorry, we got some more questions about a specific project, but but maybe both of you can talk about this, but geothermal systems in New York City haven't been a popular system previously. Is there something new or different about this particular site that makes it more viable? And do you see geothermal becoming more viable around Manhattan or around New York than it maybe currently is or was?
Yeah, this site is special because I met Will. So when I went to the Nordics, we looked at, not just free energy from the ground and not also utilizing it 100% for the building, right? We're only utilizing 40 to 25% depending on heating and cooling for the building, but we're also using it as thermal storage. So I think we looked at, honestly, geothermal 3 times, and until I went to the Nordics, did it make sense for me that it was a system for 561. So I think heat pumps will help that process along, because now you're using the same fuel source in order to store that energy, and you're connecting the two, the many systems you have in a building into one source. So I think that's probably the shift. It's more of a systems thinking shift than it is the site. There's nothing special about the site.
Mm-hmm. Is it maybe the economics of it was more viable because we had to drill new piles anyway?
Yeah, that's a fair point. It was an energy pile system, so the foundation systems were going in anyway. We just kind of piggybacked off of it. So yeah, that's definitely a fair point.
So from a technical standpoint, there may not be any reason you can't do this anywhere, but the financial aspects have to be, strongly considered, and it may not work for every building financially, but technically it really should have.
Well, financially, I would say it works. It's just a matter of time. I mean, St. Patrick's, in an existing, landmark church, put in geopiles. It cost them, $30-something million, but they still did it because they looked at it on a 30-year time horizon. And even a short-term thinking developer, that adds value to the building. So if you look at it at the point of sale, that's a value proposition. By reducing your operating expenses, you're directly increasing your value. So I just think it's a mind shift in a couple of different categories.
Mm-hmm. We are at 11:01. I still have 50 people on, so we'll ask one more question from Will, maybe this is a good question for you. How do you see, how is a solar grid more efficient in a circular economy, or how do you see the solar grid playing into the circular economy? Or is it just a piece of the entire concept?
I mean, circular economy is a sort of a whole animal itself. When we talk about technologies, we're talking about the infrastructure that will enable the circular economy to happen. So when you say circular economy, yes, there has to go a lot of technologies, a lot of systems, a lot of processes at different levels, right, with different stakeholders. But what we are talking about when you say solar, that's essentially a technology that will support circular economy and support the energy transition. So I think absolutely, solar has a part to play in the circular economy, especially if it's deployed locally and the energy is being consumed locally. And it's a part to play at energy transition at the generation level. But apart from that, it's just a single technology that is, of course, has no carbon, operational carbon, or there's no fossil fuel that's needed to generate energy. So that's inherent advantage of solar.
Sure. All right, well, we have a couple more questions, but I think we can address those offline. I think there's some on embedded carbon and materials, and I think that gets into a much larger conversation, which would be great for another presentation. But appreciate you guys taking the time to do this. I hope everyone that's still on enjoyed this. Hope you learned something. Please let people know what you learned today. I think the whole point of this was to just spark people to think a little bit differently, to get you think about other ways you might be able to work on your projects. Feel free to reach out to myself at any time. Please go to ashraeny.org for more information about our organization. This will be posted on our YouTube channel as well as the Circular City Week website. And I'll be sending out a survey later to everybody with some more of this information. You're welcome to contact Will and Mike. So Will, Mike, appreciate your time. Thank you so much. And everybody have a great day.
Thank you. Didn't know I was going to be famous.
Thank you.
Take care, guys.